Today we will identify solutions, write and graph inequalities in one variable. So here's some vocabulary. Inequality, a statement that two quantities are not equal, they're compared. So we're comparing quantities. So if you have the little caret where it starts pointy and gets wider, that's the symbol for less than. If you flip it around, it's the symbol for greater than. If you throw underlines underneath them, less than or equal to, and greater than or equal to. And then a solution of an inequality is any value of the variable that would make the statement true. So if you need to, you can pause the video here and take down any notes that you need. So if x was 3, would that be a solution of this inequality? X is greater than 2. So if x was 3, would that make this statement true? Yes, it would, because 3 is greater than 2. What about x is less than 2? No, 3 is not less than 2. So if we put a 3 in here, that would not make a true statement. What about x is greater than or equal to 3? Yes, because 3 is equal to 3, and this says greater than or equal to. Since the inequality x is greater than 5 has an infinite number of solutions, we can use a graph on a number line to illustrate the solutions. So let's see what that would look like. All right, so we have x is greater than 5 up here at the top, and we have a number line down here. So we're looking for values of x that would be greater than 5. Well, 3 is not greater than 5, 4 is not greater than 5, 5 is not greater than 5, but 6 is greater than 5, and everything this direction would be greater than 5, right? But what about 5.000001? That's greater than 5. So we need to somehow indicate that everything past this number is greater than 5, but we're not actually including 5. So the way we do that is we put an open circle where 5 is on the number line, and we say everything this direction. So 5 and everything this direction. You can put it on the number line too, like this. All right. So 5, everything that's greater. So if you have an open circle, we're going to use that for everything that's greater than or less than. A closed circle is going to indicate greater than or equal to, or less than or equal to. So this is not including the number that you have the circle at. And this is including the number. Let's connect that there. All right. So let's think about this. What about x is less than or equal to -1? So let's say we have a number line here. Try to make this better than the first one I had. All right, so let's say we have 0, -1, -2, -3, -4, and 1, 2, 3, 4. So less than or equal to. So that is including the number because it's or equal to. So we're going to have a closed circle here. And I'm going to do it above just because it's kind of easier to see what's happening. But you can draw it on the number line itself if you'd like. And then it's going to include every number that's less than -1. Is 0 less than -1? No, it's greater than -1. So is -2 less than -1? Yes, so I'm going this direction. Let's do that nice little line thing. All right, so we're doing everything this way. All right, and then everything this way. So that is how you graph these inequalities on a number line. All right, so now let's look at solving some inequalities here. Let's kind of box off the section we've used. All right, so when you're solving an inequality, for the most part, you're going to solve it just like you would a regular equation. So I'm looking here, so just like I would if there were an equal sign. Since 3 is being multiplied by x, I'm just going to divide it. And then I have x on one side and a number on the other side. So x is greater than 3. And that's all I have to do. But if you wanted to put it on a number line here, let's say 0, 1, got ahead of myself there, 2, 3, 4, greater than, so we're not including the number, but we are including everything greater than. All right, so we solved it just like we would if there were an equal sign. What about 3 plus x is less than or equal to 9? Again, I'm solving it just like there were an equal sign instead of an inequality. So I'm going to subtract 3, and I get x is less than or equal to 6. So again, if I wanted to graph that, we'll say 7, 6. On a number line, we're including the number, so it's going to be a closed circle, and we're including everything that direction. All right. So let's look at some more examples here. Get this done a little bit faster. All right. So x minus 3 equals 9, or sorry, x minus 3 is less than 9. Just add my 3, add my 3. X is less than 12. So you see I'm not doing anything different. 12. Open circle because it's less than. And I'm including all the numbers less than. There is one exception to this rule. Let me kind of piece this off here. If you multiply or divide by a negative number, you flip the sign. You flip the inequality sign. Let's make that clear. The inequality sign. So these signs over here, these signs here, are going to be flipped if you multiply or divide by a negative. So let's see what that looks like. I have negative x divided by 3 is greater than or equal to 9. Well, if I multiply this by a negative 3, I'm going to get rid of this negative and get rid of this 3, and I'm left with x. And over here, I'm left with negative 27. But this sign right here is greater than or equal to, but since I divided by a negative number, I have to flip it and make it less than or equal to. So this greater than or equal to became a less than or equal to. If you multiply or divide by a negative number, you must flip the inequality sign. If you want to go ahead and practice this, you can go to IXL Algebra 1, sections K1 through 6. See you in Zoom.